the week. Okay, so we're going to switch gears to the homework assignment to share. All right, so let's go back. So let's go to Brightspace. It's still going. All right, let's go to Brightspace and let's go to the table of contents. So we are here, PyCrypto. So this is the next set of problems that we're going to be working through. No longer breaking RSA, right? So we're kind of a little bit done with that for now. We're just going back to just encrypting. So let's take a look at the document here. So I'm not going to assign a homework this week. It'll probably be because we need to do a lot of scripts until you can do this homework. But let's read through it first. So this is actually a very important homework assignment, okay? So the Python cryptography toolkit used to be called PyCrypto, then it became PyCryptoDome. For those of you that have the book, you'll see in the book in the cyber chapters that it uses PyCryptoDome. So it's a very popular library for this. The difference is so far, mostly in the semester, when we use Python, we've implemented the algorithms from scratch. We use OpenSSL, right? So this is going to be a third option that we have now where it's Python, but it's a library also. Okay, so let's take a look at it. So in these problems, using PyCryptoDome, send a secret message to your partner, use symmetric encryption to achieve confidentiality. The symmetric key must be exchanged securely via RSA. Number two, send a second message. This time you need to provide confidentiality, integrity, and authentication all in one shot. What I mean by that is you can only send one email only, and everything has to be secure, meeting all of these requirements. Do you see that? So now we need to do all this. We're going to explore authentication also with RSA. Number three, so you can use email to exchange the files. Okay. Yeah. And number four, and these two are important. You need to also complete a report and submit it. And number five, you will need to demo both problems. So what I mean by this is we're going to take a day, a Thursday, and I'm going to sit with you guys, with every, the partners, and you need to demo these two problems to me. So I need to see you actually do it live. Does that make sense? And in that I do that because I have found that students actually don't understand how to do it exactly. So that's my way of making sure. Okay, so I will sit with, the partners, and you need to essentially send the message and everything securely. Got it? So you'll need to create the keys right there, encrypt the file, and send it from one computer to the other via email. All right. So what I'm going to do now is I'm going to start giving you the scripts, and I'm going to start explaining how they work. These are all obviously, as usual, posted on the GitHub, so you can get them from there. But we're going to work through all of them. All right. So now we have with PyCryptoDome, all the libraries, all the functions that we need to achieve all of these things. But we just have to learn how to use it. All right. So that's the set of problems. I haven't assigned this yet. I'll probably do that next week. So let's just get started then. So we need to go to the VM again. Okay. I'm going to open up another terminal. All right, so let's open up another terminal. All right, here we are. Now let's go also actually back to the module on Brightspace. So I put a few things here. I used to give students the actual tar file so that you could install things on your VM. But now you can just use pip install with Conda, so it should be easier. This link here, if you click on it, PyCryptoDome, it takes you exactly to the support page for PyCryptoDome, the library. You can see we're going to do something like pip install PyCryptoDome, right? So that should be the command that we need. Again, we need to watch out for the version of Python that we're using. 3.7 hopefully should be good. And that's really the only library that we need to install. But you can read through this if you'd like. There's a lot. It's all related to cryptography. So there's a lot of examples and a lot of more details than I will give you. So it's a nice page for you to read. Okay, go back here. And now, so crypto code. So this should just take us to the repo, obviously, and then the scripts should be under this one. Do you see that? PyCryptoDome? So yes, you can see there's a lot of scripts. For this one, this is a really important set of scripts because it's a lot of what we're going to be doing that we've done so far and some of the things that we will be doing going forward, like digital signatures, for instance, right? So we have to cover all of that. Okay, we'll start with the most basic things, which are going to be symmetric encryption. Okay, guys? All right, so let's go ahead and get started. So I'm going to go back to the virtual machine. All right, so again, pip install PyCryptoDome, right? So that's what you would have to type. All right, so I'm going to navigate to my folder now. Fall 2025. There. And because there's so many of these scripts and they're not all about RSA, I'm just going to create a new folder. Call it PyCryptoDome. Just gonna put my there. I'm always careful when a folder I create has the same name as the library. There could be a conflict sometimes when you do import PyCryptoDome. So just be careful with that. So that's why I'm adding this my at the end. Okay. So now we can cd into this folder. Okay. Perfect. So now we can start. I'll do the first example. remember with these, so there's multiple scripts, so you'll use, we'll have a script to generate the keys, and that's it. Then you'll have another script when you need to do symmetric encryption or when you need to do a signature, right? So all of these are going to be shorter on the shorter side. So let's go ahead and create the first one. You guys have any question? No question? All right, so let's do the first one, going back to just symmetric encryption, right? Just to get a feel for it. So I'm gonna call it AES underscore encrypt. .py. So the first thing we need to do is just create a folder, make sure we can use PyCryptoDome, there's no errors, etc. And then after that, it should be more straightforward to create all the other ones. Okay, so the way that it works is you do from crypto dot cipher import AES, right? So that means we need the AES algorithm. We always have this notion of random. So I'm going to also PyCryptoDome should provide its own random library. I'm going to do from crypto dot random sorry, import get random bytes. Random underscore bytes. Okay, so these should be the only libraries we need. So Control X, Y, Enter. Okay. Now let's try this. Python. Okay, perfect. For me, it worked. Did it work for you guys? Excellent. So that's what we want, right? So it's working on 3.9. And I think hopefully we all have the same version of Python. Be aware if you get an error at some point and your friend is not getting an error, the best solution might be to ask them what version of Python they're using and switch to that in your environment. Otherwise, you may need, if you stick with your version of Python, what may happen is you have to make tweaks to your code. Do you see what I'm saying? And my code won't work. All right, so now that we have this, let's just get some basic functionality going on the script. In this case, this one is an AES cipher. So what are we doing? We are going to encrypt a message, correct? Do you guys agree? So which principle are we worried about? Confidentiality. All right, some kind of a message. Also, by the way, these are some of the scripts that will be used on the scavenger hunt as well. All right, so I may encrypt some things using these. So we want to become familiar with them. So we need to create some data, right? And then we're going to create a key. Okay, so let's create a key here. So I'm going to create a random key. I'm going to call it secret key. Usually when I use the word secret key, I mean a symmetric key, like from AES or DES. So let's call it secret key. And we use that function get random bytes. Get random bytes. And the size of this is going to be 16. Okay, so 16 is what I'm using here. All right. Okay. Calix. Okay, perfect. So it worked. So we're able to generate the key. if you notice, this symmetric key is something that you need to store somewhere, right? You need to store the key. So what we're going to do is we're going to create a file that holds the key. Now, this key is unencrypted, so obviously you can't send this file to your friend. You would have to first encrypt the key and then you can send it because this is the symmetric key. Make sense? Questions? All right. So let's go ahead and look at the code. And we'll be writing bytes and reading bytes essentially. So I'm going to go ahead here and I'm going to create a file key. And that's why I've said several times that this assignment has many files. There's a lot of files because you're creating many keys and things like that, messages, binary signatures. And so the point of this one is to know which things you need to send securely, right? So that's really the essence of a demo. I need to make sure that you're not sending something that shouldn't be sent. All right, so file key, open, okay? And this is going to be called the AES key. AES key dot txt or some extension, doesn't really matter. One thing that you have to be careful here, if you remember, everything is like bytes and things like that. So we need to use the bytes symbol. In this case, we are writing bytes, so WB. Okay, so WB. Okay, and then we're just going to say file underscore key dot write. Okay, and what do we write? We write the secret key. So this way now you have a key, a symmetric key that you can use. All right, and then we close this one. So file underscore key dot close. Okay. So let's try this. ls-l. So there's only the script. Now I'm going to go ahead and run it. It ran, no errors, no issues, right? But if we do ls-l, what do we have now? We have the AES key.txt file that holds our key, okay? So we can do something like cat AES key, and you can see it is essentially a binary. All right, so that's the first step. So we can create the symmetric key. Obviously now, when you want to communicate securely with your partner, you're going to have to send that information securely via what? What would you use to send that secret key? RSA, right? Exactly. Very good. So RSA. Makes sense? And so, yeah, perfect. So, so the next thing is to encrypt a message. So we're going to need some data. So your data can come from, and I do recommend that you actually put even the message in a plain text file, okay? During the demo, I will ask you to open that plain text file and I will give you the message. So like whatever it is, I'll say today is Thursday, November something. All right, and so you'll have to use that information that I provide in the plain text to do the whole demo, okay? For this example, I'm just going to hard code it, but we'll do other examples where we actually read it from a text file. So I just want to show you something here. So I'm going to give you some data. PyCryptoDome has this peculiar thing where it wants everything to already be binary. So it does, it works sort of like that. And so we just need a little trick to convert our strings to binary when encrypting things. So I'm going to go ahead and first create a message. Okay. I'm going to say, this is a simple one, RC So 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4, 5, 6, 7, something like that. Okay. We're going to add in front of this string the letter B. And in Python, that basically typecasts that string to a byte array. Got it? And that other, if you don't use this, it can give you an error. All right, so now that we've established that, so we have the data that we're sending here as a message. We've also created the random key of 16 bits. We've saved it into a file in plain text, so it's not just because it was unreadable doesn't mean that it's secure. Okay, so now we need to create the cipher. So I'm going to go ahead and do that. Cipher underscore AES. And this is how PyCryptoDome works. If you notice here, we imported the AES module. So now we're going to use it. So I'm going to say AES dot new. Okay, and I'm going to instantiate it. Okay, a new AES module. So the AES algorithm for symmetric encryption. The advanced encryption standard. What do I need to give it? I need to give it the secret key, which is our symmetric key. And I can specify the mode of operation that I want. So you guys remember the modes of operation, right? CBC, ECB, all of those. Okay, so we're going to do AES dot mode underscore CBC. Got it? All right. So we instantiate it. So let's try it. Oops. Okay, hit clear. All right. Let's now do, yeah, let's run it. Okay, it worked fine. So that means we're able to instantiate it. Now we're going to proceed to encrypt something, that message. So we come down here, and now we create ciphertext, and we invoke cipher underscore AES. That's our algorithm. And we're going to say dot encrypt. Okay. And what do we encrypt? We encrypt the data. You guys see that? So we encrypt the data. And then we need to save the information, right? So we need to save this into a file because that is actually now encrypted, right? So that's secure as long as you keep the secret key secure using symmetric encryption. If you remember, CBC had something at the beginning, a vector that we needed called the initialization vector, right? So we need to, we've used an IV here, so we need to send that to your partner so that they can actually do the decryption process. So I'll show you the best way to do this is to actually like encode it in the file itself. Does that make sense? So essentially we'll have the encrypted message and we can append in front of it the IV. So the first 16 bits are going to be the IV, not the key, the IV, and then followed by the message. So when you receive it, you have to get those first 16 bits for the IV, and then the rest is going to be the message itself. Got it? Any questions on that? All right, so let's go ahead and try this out so that you can get used to it. So I'm going to do file out. This is the file that you would send to achieve confidentiality. I'm going to say open. I'm going to give it a name. You should use proper names. So AES encrypted bin. Okay, AES encrypted.bin. comma, and then of course we're writing bytes, so we're going to say WB. We're writing bytes. Okay, so now we need to write to that file. So we're going to say file out dot write, and the first thing we're going to write is those first 16 bits. So that's the IV. So the IV is a parameter in here, right, in the module in cipher AES. So we just need to provide that. So we can just say cipher underscore AES dot IV. Got it? So we just write that first. And now we write the actual cipher. So we're going to do file out dot write. And what do we send? Ciphertext, right? So we send ciphertext, cipher underscore text, just like that. Okay, and then we just need to close the file, and that's it. So we do file underscore out dot close. Okay, and that's it. That's the whole script. So Control X, Y, enter. (16-byte boundary). Oh, data. Okay, so let me see. Yeah, so the data, maybe I have a missing character here. Give me a sec. So RC, I have a 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Yeah. Yeah, so that's one thing about PyCryptoDome. It's not doing the padding for you. So you have to watch out for that. So let's see this one. Yeah. So yeah, but I'll provide the code, and we've done examples of this before of how to deal with padding. Okay, so we'll just either need a function for padding or just be careful when you're doing your 16 bytes. Okay, any questions about that? All right, so I'm going to do clear here, ls-l. All right, and there we are. So now I have a file that you can send, right? So which one of these 3 files are you allowed to, can you send securely, essentially? The bin file, right? So the bin file is actually encrypted. So remember, when you do the demo, these are the things that I'll be watching carefully, right? If you send, for instance, AES key.txt, that's wrong, right? So you made a mistake. So that's what I want you to focus on in this assignment more than anything. So I'm giving you all the code. There will be very little coding that you have to figure out on your own. Just learn how to use these scripts well. And it's essentially, I'm making questions like, I'm giving you questions like, okay, achieve integrity, achieve confidentiality, achieve authentication, do it all in just one email, and so on. Okay? And so that's really the essence and the tricks that you need to learn. All right. So I'm kind of curious to see if this thing ever finished. It didn't finish. All right, so it's still going. So I'm just gonna kill it, but it would have been nice to see it break that. Just taking a long time. And I think it's consuming a lot of my resources. It's really. All right. All right, so we did that one. Let's do another one now. The one we're gonna do is the one that would decrypt this message, right? So let's go to the other end. We're gonna need to, and like I said, there's several scripts we have to cover, so I'm just doing 2 today, but these are 2 important ones because first of all, we have the library installed. We know it works without errors. That's the key thing. And then next week on Tuesday and Thursday, I will give you the rest of the scripts until we've covered everything. All right. So the next script that we need to do is AES decrypt. Okay. So let's go ahead and create a new script now. I'm going to call it nano AES underscore decrypt dot py. I used uppercase for these, so it's become consistent. Okay, nano. Right. Okay, so again, we need the libraries, pretty much the same libraries. So from crypto cipher, the crypto.cipher, import AES, right? So we need AES again, right, guys? Okay. That random function, you know, just add it. We may not need it here, but from crypto dots random import the function get random bytes. Get random bytes. All right, so now what do we need to do? We need to read in the file. You sent the encrypted file, the encrypted message via email, the bin file, so we're going to read it. So let's call it file in. And then I'm going to open just like that. And the name of the file should be AES encrypted dot bin. Okay, we are reading, but we are reading bytes, so you want to say RB. Okay, reading bytes. All right, so now we need to kind of reverse the process that we had before. So we need to read in the first 16 bytes, which are the IV. So I'm going to create a variable called IV, the initialization vector from CBC. Mode of operation. So I'm going to say file in dot read. Read. But we need to specify here 16 so that we're reading 16 bytes. On the scavenger hunt or somewhere, I could change the key to be 32. So you just have to watch out for that. Okay. All right. So I read in the IV here, and then I'm going to read the rest of the message. So I'm just going to say ciphertext file in dot read. So there's kind of like a pointer pointing to the buffer. So essentially it's gonna pick up from, you know, it assumes it's read the first 16 bytes. So then here it just reads the rest. Okay. So that's the idea. And then we can close the file. So I'm going to do file in file underscore in dot close. Oops. Yeah. So essentially here we should have now the message that was received and the initialization vector. Let's try this one. Python. All right, and it worked great. So we were able to read the file in. And now, so what do we need next? We would need the secret key, right? So we used the secret key. Now remember that secret key, for you to send it to your partner, you first have to take that and encrypt it using asymmetric encryption, such as RSA, right? In my example, I haven't done that, right? So, but I do have the key in a file, right? That secret key file. So I'm just going to read that, but when we actually implement this correctly, you have to take that file and encrypt it into an encrypted version of the key, send that. Then when your partner receives it, they have to take that and decrypt it, right? To the point where you have AES key in plain text format. So to do that, I'm going to call it file key. Okay. And I'm just here because it's already decrypted. I mean, it was never encrypted. So I'm just going to go ahead and read it in. And that's going to be the file AES underscore key dot txt. All right. Comma, because it's bytes, we have to say RB. Okay. And now we read in the key from this file. So I'm going to say secret key and then file key, file underscore key dot read. And we just read in the bytes, which are 16 bytes. Okay. And then make sure to close the file. The file key dot close. Okay. So now we have the key, we have the cipher, we have the IV. We just have to proceed to instantiate the AES algorithm and perform the decryption. So I'm going to create a variable called cipher underscore AES dot, and then that's going to be, we have to call AES from the library. So I'm going to do AES dot new. And then I need to provide all the parameters. So I need to give it the secret key, comma. I also need to know the mode of operation. So be careful with this, right? Because what if on the scavenger hunt I use ECB, right? So you need to be aware of that and what it means, right? So you guys know what those mean. Remember also that ECB does not need an IV, right? But CBC does. Okay, so here I'm going to say AES AES dot mode underscore CBC. Okay. And finally, IV equal IV, just like that. Okay. So if that's correct, let's run it. Okay, no errors. Good. So the code is working fine. So now we just have a couple more lines of code to do the actual decryption. So I'm going to create a variable called decrypted message cipher underscore AES dot decrypt. And what do we decrypt? We decrypt cipher text, which should be this variable here. Make sense? All right, so cipher text. So once that's done, all that remains is to print it out. So we can just go ahead and do print decrypted message. All right, here we are. Okay, so let's try it. Let's see if it worked. Control X, Y. Did it work? What do you guys think? Yeah, it did, right? Because that's the message that I had originally. So yeah, so that's essentially good progress today. I've introduced AES. These two functions are key for symmetric encryption. You guys already know that AES is more secure than DES. CBC is a really good mode of operation. So essentially you have two really nice functions to achieve confidentiality. All right. So yeah, so we're gonna stop here for today. On Tuesday, I will wrap up some of the lecture with RSA, and then just continue with these functions. And I think by Thursday next week, we'll finish all these scripts, because I have to introduce new concepts like a signature and things like that, authentication, or new ideas actually. But we should be done with the code at least. And then I'll assign that homework, give you a little bit of time, and then you have to do, as I said, a demo for it. All right, guys. So I'm gonna end the video here. I'll post the